So what I'm trying to do here is get rid of all of the capital expense and only leave you with operational expense, so to speak. So you will hopefully feel like you have a template or an example of how to do almost anything, and then you can go and build your own products with this. What is really important to me here is to create a system that uses the database as the source of truth. We are not just using plain tables and perhaps some indices or something like that, which you may be tempted to do if you're using something like an object relational mapper normally, which means that we're going to be migrating it using on full stack TypeScript development using Tailwind CSS on tRPC and modern features of Postgres. Yeah, we probably should have thought of a shorter title, but it seemed to me like all of those things were important, so that's why I left it all in. My name is Kristian Dupont, and throughout this course, I'm going to be guiding you through what is currently my favorite stack for building web apps. I still want to retain a high level of type safety throughout the system, and I'm going to be showing you what we are doing to achieve that, because that seems to me like it's the biggest advantage to this architecture, and it's a quite nice thing to have once you have it in place. Will be based on Node.js, the Koa server framework, the query builder called Nex, and then on the front end, we'll be using React. And the prerequisites for you is to be fairly familiar with TypeScript development and hopefully Node.js and React a little bit. You should also know some basic SQL, because we will not be going into the details of all of these things, but only cover them quickly. I'm using VS Code with Prettier and ESLint extensions installed. So I'd recommend you do the same unless you have a good reason to do something else. That will make it easy to understand what I'm doing in the videos. The other prerequisite is that you have both Node.js installed and then either the Postgres server or Docker, which you can then use to run a Postgres container. And I'll be showing you how to do that in a one-liner throughout the course. So with all of that, if you're ready to go, let's get started. We're going to be using a monorepo for our architecture. That means a single repository for everything, in case you're not familiar with the term. And if that's the case, then it might strike you as a little bit lazy or messy, perhaps. I think as engineers, we all have some slight OCD, and we tend to like to put things into boxes. It's just sort of a natural instinct to us. We like to make things nice and orderly, and setting up repositories from the start feels like a very nice way of starting a new project. And it's definitely a good skill, or a personality trait in a developer, because I think we all know that being overly pedantic about details that might otherwise seem trivial is what makes a code base maintainable in the long run. You have to care about details that normal people, if you will, would simply go, really, is this really necessary? But to engineers, yes, that is absolutely necessary. But this also means that I think that this is a personality trait that we need to keep in check a little bit, because it feels like a virtue, and so it's easy to let that just run and not control it, and it doesn't always add value to what we're doing. So I have this little, well, it's not a timeline, it's a journey. I call it the code journey. And this is just a general guideline. It's absolutely not a rule that must be followed. I break it all the time, but it's just an idea to get you started. So this is how I think about code when I'm writing something new. I will tend to start it in line. So if, say, I'm writing some new UI code, I will possibly just start it inline in the component that's going to be adding this UI. And only when I figure out that, okay, this is on the right track, when I'm starting to get a sense of what I'm doing, then maybe I will extract it into its own component. And as that component grows and becomes perhaps useful to other files as well, then I will move it into its own file. Now, I often start with creating a file from the get-go, and I even start further to the right in this line, but as a general guideline, it's good to start like this, I think. I will then see where this file belongs, and the more I use it, the more generally applicable it becomes, and the more generic it becomes, the further up in the directory tree I'm going to move it. My directory tree tends to sort of mirror the levels of abstraction in the code. This doesn't this doesn't match 100%, and it's not always applicable, but that does sort of seem to be how things work, at least the way I end up structuring my code. The last folder that I will probably have is some sort of shared folder. At least I typically have that for components and hooks. It's a little bit different for other things, but maybe there's going to be a util folder for the server or something where I have really generic stuff that can be used all over the place. But if I find out that this is actually something that can be used by multiple packages, or it really is very generic, then maybe I'll create an npm package, so to speak, in my monorepo. I'm going to be going over this when we reach the workspaces lesson, because we're going to be using workspaces, which is sort of a way to create little npm packages in your repository. And then finally, if something is actually useful to others, or I just feel like this is something I'm going to be using in more projects, then maybe I will end up creating an npm package, because then it's just so generic that it really should be published. It could be a private package, but I prefer to try to make things open source if that is possible. So from that perspective, I would argue that a monorepo is at least the obvious place to start. Even if you decide later on that it doesn't work for you for whatever reason, it is just the simpler solution to things, just having one place for everything. So why not start there and then split things up if you decide later on that it just doesn't work for you? There are some significant upsides to having everything in one place. For instance, it's much easier to share things like linter settings and TypeScript configurations. We're going to be looking at that in a following lesson. More importantly, though, I would say that the fact that everything is synchronized, so for your services, the backend and frontend, and possibly other services if you have them, for them to be synchronized in, say, a branch, makes it much easier to try out things that are requiring changes in both of those or more of those services. It's also easier for onboarding when you have a new team member, because there's just one repo that they need to check out and they will have everything there. There are some downsides to it as well. For instance, there's a higher risk of merge conflicts, which is obvious when you just have one repository. Everybody's going to be working in that at the same time, and there's a higher chance that there's going to be some conflict somewhere. But in my opinion, this is actually an expression of a conflict in the structure itself. And so if you didn't have it in the monorepo, you would probably just be experiencing this in a more unpleasant way at runtime in one fashion or the other. There can be an issue with disk space if the repo grows very large. I know that both Google and Microsoft have solutions for this, with actually doing something particular with Git. I'm not sure how that works, but this is something I have never experienced anywhere. So I think that's a very limited problem for most people. You may run into a situation where your linter settings and TypeScript configurations and what else you have doesn't actually work for every project in the repo. And so maybe that shared thing loses its value. That's a potential, but that also seems like a very trivial thing to me. The last thing that could be breaking this is if you have some compliance rules. If one team is simply not allowed to work or see a piece of code, obviously that might create a tension for you. But we're going to assume here that there are no specific compliance rules. I don't think there would be for a booking system anyway. So we are going to use the monorepo, and hopefully you will be able to as well. So we're going to be using something called workspaces. That was introduced by a package manager called Yarn a while ago, but it is now supported by all the major package managers. I'm going to be using npm in this course because it's the standard, and I think it works very well. But you're free to use any of the others, pnpm or Yarn or whatever you want, because I think all of them support all of this that we're going to be using in this course. There are tools for managing monorepos when your project grows larger that you might want to look into, such as Lerna or TurboRepo. Those two both use workspaces internally, but they offer some additional features. So they might come in handy at a later point, but for all that we will need it for right now, we will be using just workspaces, and that will work just fine. So let's get started. I have a completely clean VS Code session here, there is nothing in this folder. I just created a folder called Easy Booking, and we will start working in that. So I will start, it hasn't even been initialized for Git. So let's just initialize a Git repository, and then we will say npm init for initializing package.json in the root. It will ask us some questions, and we will change this to easy booking -monorepo just to keep track of or make sure that we remember that this is the monorepo package JSON. It's not really something that is a package in and of itself. The rest of these questions aren't really interesting. We can set the license to unlicensed, just because this is not going to be something we will be publishing. And we now have a package JSON here in our folder, which contains these things. I will add one thing to this, which is private. And the reason for that is that it's, at least it was in Yarn. I'm not sure if NPM requires it, but it used to be at least a requirement. And it is to make sure that you don't accidentally publish your monorepo to the NPM registry, which is certainly not something you want to do. Now, there's sort of a tradition of having a folder called packages in your monorepo where you will put all your packages in. I personally like to also have something called apps or services, which is where I put in the particular packages that will sort of spin up. So packages itself will just contain shared libraries, and then services will contain the things that I actually deploy somewhere. So let's create two folders out here in the root. Packages and services. Did I spell that right? I did. There we will put our stuff into those two folders. The architecture that we're creating here is really quite simple. We're going to have two services, a backend and a front end. And you can argue that the front end isn't really a service, it's a bundle. But for this course, we're going to talk about it as a service. And then we're going to have one shared package called schema. The schema will take care of database migrations, but it will also be where we supply our TypeScript types, both to the backend and to the front end. So that is where Kanel will be generating the types. Let's start by creating the schema package. So I go into the packages folder here, and I create a schema folder. And in that, I will run npm init again. And you can see that fish shell is squealing on me that I've done this before. But what we're doing here basically is we will be using the scope parameter to npm init. So basically, we're going to tell it that we're going to be creating this schema package in the easy booking scope. And all that really does is you can see it suggests this name, and that is what the scope means. So this is now schema in the easy booking scope, and we're going to accept all of these things that it suggests for us, because we don't really care much about any of this. So now we have the schema package. Let's go and do the same thing for the backend package. So that is in services. We'll create a backend folder, and we will run npm init, and we will use the scope parameter again. So we do this, and we just accept everything it suggests for us. And we now have a package.json file in schema, and we have an almost identical one in backend. Nice. So in order to use these in the workspace, we need to add them to our package.json out in the root. And the way we do that is by creating a workspaces entry here. And that takes an array of things. And you can see that Copilot here is suggesting that I add packages /*, which is a quite common way of doing this when you create monorepos, but I don't particularly care for it. The reason is that when you do this, you don't specify the order of things. And since we're not using Learner or TurboRepo or anything that handles that sort of thing for us. We can do very, very basic dependency management by just specifying the order of packages out here. And we want to make sure that whenever we build our backend, the schema has been built first. So we're going to add packages/schema before services/backend, and add a comma there so everybody's happy. I don't think there's much of a hassle to have to add all the things that you want in your workspaces to package.json. That adds a little bit of plumbing, but it's definitely something you can live with. And this way it's explicit, which I just find is nice in every way. So this way we will have the dependency specified. One of the nice things about using a monorepo is that it makes it very easy to share configuration files across the projects. And we're going to be doing that for TypeScript and also for ESLint and Prettier and possibly some other tools. But let's start with TypeScript. So let me actually just start by committing this to Git. And I'm just noticing a typo here. Let me just fix that real quick. And I will add all of this. We should also create a git ignore. Let me just do that and then actually create a git ignore. I tend to use this gitignore.io for just creating a quick file. So if we take this and we add a gitignore file here. This is just a predefined one for Node, and it has a bunch of things that we don't really need, but this works reasonably well, and it will work well enough for all that we're going to be doing here. So we'll add that to our repo, and then we should be good to go. I think I misspelled there again. I can't see my keyboard here. I apologize. So in order to set up TypeScript, we're going to go to we're already in the root folder. So we'll install TypeScript like so. And then we're going to need some configuration. And TypeScript is heavily configurable, so that can be a bit of a jungle to navigate. I tend to use this package on NPM called tsconfig, which has a bunch of recommended configurations that I tend to use, as long as I can at least. And TypeScript configurations are quite easy to append to. So we're going to be doing that. So we're going to be starting just with a recommended configuration. So I'll add this package, tsconfig/recommended. You can see it's been added there. And I can now create a TypeScript configuration in the root folder here. So I'll make a tsconfig.json file here. And I'll just say this should extend the recommended tsconfig, and I think I need to specify like so. So this is a very basic. Now we're simply using the tsconfig recommended setup. The package has recommended for specific setups like Node specific versions and other things, but this is a fine place to start, and I like to do this and just expand whenever it's necessary. One of the things we're going to want to do immediately is we want to tell TypeScript about our packages, specifically our schema package. The reason why we're doing this is that it helps our IDE. So if you're using any IDE like Visual Studio Code that has the TypeScript language server, you can go to definition or go to implementation. And it's just a bit nicer when TypeScript knows about where that package is, so it won't just try and go into the node modules folder and look at the .d.ts file. So we can do that by extending it with compiler options. And we'll add first a base URL that says packages, and we will add a paths entry, and that here we will refer to our schema package, and that needs to be an array, and that is the path to our schema package. Now TypeScript should be able to go to the definition of anything in the schema package by actually going to the folder where it's implemented instead of the node modules folder. This is obviously in the root, so this is not actually what any of our projects are going to be using. What we need to do is to create specific TS configs in the folders for our project. So let's create one in the backend folder. I should mention maybe that TSC, the TypeScript compiler, has an init function just the way we used npm init and git init for that matter. That can create a TS config file for you, and you can specify some things there, and you will get a nicely formatted configuration file with lots of comments in it. So it's fairly easy to navigate. I just find that when I'm using these recommended configurations, it's much easier to create the configuration file by hand like I'm doing at the moment. So you could be using tsc-init, but we'll just be doing this like so. So what I need to do now for my backend TypeScript configuration file is reference the root tsconfig here, which again then references the recommended configuration. So it's a little bit of a chain of configurations, but it works perfectly fine. So here we will start by adding an extends, and we will say that it extends. This is the services folder. This is the root folder, tsconfig.json. And then we can now add some specific things to our backend configuration. And the only thing that we really need to add here is we want the library to just be ESNext, because we simply want to just use the latest version of the JS libraries. This is something you can change if you find that your setup, for whatever reason, doesn't work with this library. But as it is, we're going to be using this. And then we will specify an out directory. So this is where the compiler will add everything. And we want this to go into a dist folder, like so. Finally, we want to include everything in the source folder, which we don't actually have yet, but we can create one of those. Let's just copy all of this and create a similar tsconfig file in the schema folder. The only thing I want to add here is that because the schema is a shared library that's going to be referenced from the backend and the front end, we want declarations created. So this is an option in the compiler options as well. So declarations mean a .d.ts file which specifies the types of things, and we want that created for our schema so that all those types that we're going to be referencing are actually available to us. Right. We obviously need to set up TypeScript for our front end as well. But the reason I'm not doing anything for the front end just yet is that we're going to be using Vite, which is the bundler, for creating a sort of a scaffolding for our front end. And that includes some various configurations, both for linting but also for TypeScript. So we're going to be using that first, and then we'll be refining it a little bit from there. So this is a good start for the backend and the schema configuration. We want to make sure that the schema configuration or the schema is referenced correctly. So we'll go into the package.json and change this. So we are not going to be having our index.js in just the root folder of the schema package. It's going to be in the dist folder, which doesn't exist right now, but TypeScript will create that for us. And we will add to this that there will be types going into the dist folder as well. And you can see that Copilot is helping me here. I thought I disabled it, but I will just do that now because that feels like cheating. All right, so now the schema package should specify correctly that the types and the compiled output will be sitting in the dist folder. Next, we're going to add Prettier. Prettier is a code formatter that is highly opinionated and quite aggressive about how it formats your code. If you're not familiar with it or not used to it, and you're anything like me, it might make you a little bit uncomfortable. It certainly did for me when I started using it, but I can tell you now from experience that I would hate to work on a project that doesn't use it. It is incredibly addictive once you get used to it. You just start being used to saving, and then everything is formatted, so you don't even have to think about it anymore. It is very, very nice. So if you're not used to it, I encourage you to try this out. Let's install it in our project here. We will start by adding Prettier to the root. And then we will create a configuration file. And this is actually an optional step, and you could even argue that it's a little bit of an anti-pattern, because Prettier is opinionated for a reason. It's not really supposed to be configured a whole lot. I just happen to like semicolons and single quotes so much that I tend to configure it like this. But this is a very optional step. If you don't like that configuration or you don't care, then definitely don't do this. And I might even add that I've worked personally on other projects with different configurations. And once you're used to working with Prettier, because it formats everything the way it's supposed to be when you save, you just stop caring about whether you used one or the other, and it almost doesn't matter. So this is a very optional step, but we will do the way I normally do right here, and so that is, I like semicolons, so we'll set that to true, and I like single quotes, so we'll set that to true as well, and that is our configuration of Prettier. Now, we want to enforce this formatting on CI. So I like to have Prettier format everything when I save, and I encourage everybody to do that. But in order to make sure that the formatting is kept, we will make ESLint check for it. But ESLint isn't even installed yet, and ESLint is one of the other things that we will have shared configurations for. So I'm going to install that together with a bunch of packages that we need for ESLint. So let me just add that here. Let me just go through these real quick. So ESLint is the linter package itself. Then we add the plugin for Prettier and the configuration for Prettier. And there's a very good reason why these are two separate things, and I'll get into that in a minute. We also add the TypeScript parser for ESLint and the TypeScript plugin for ESLint. So once that's installed, we will create a ESLint configuration file, and that is called ESLint rc.json. I believe they're working on a new configuration system. They're revamping the whole thing quite heavily, but at the time of writing that isn't out yet. So this is still the way you configure ESLint. I'm just going to quickly copy the setup that I have from the article, and then we will go through it quickly. So we want this to be the root config. What this means is that ESLint is not going to go up any parent directory and look for configuration files further up. That is both a performance issue, but also, even though you might be tempted to have your own personal preferences sitting in a top folder somewhere that ESLint would always enforce, I think that is a bad way to go about it. Every repository should be completely self-contained, and you want everything to work the same way when you check it out on a new machine as it did the previous machine. So having the root folder contain the root ESLint configuration just seems like the right thing to me. We specify that we're going to be using the TypeScript parser, and we give it some options. This could probably be like latest instead. This is just how I have it set right now. So 2017 ECMA version works fine. Maybe it's time to update that, but we'll leave that be. We're using modules as our source type, and we should use the TS configuration that sits out here. We're then adding the TypeScript ESLint plugin, which adds some TypeScript rules that we're going to be enforcing, and then we add the Prettier plugin. And the extends is the configuration itself. So we're going to be extending the recommended ESLint configuration. I think this is a nice way to go about things. There are a bunch of rules here that apply to almost any JavaScript or TypeScript project that you might want to use. So I just always add this one when I'm setting up something new. The same goes for the TypeScript recommended set. There are very few exceptions to this. And then we add the prettier setting as the configuration as the last step. And it's important that that comes last because that needs to override anything that comes before it. So any ESLint recommended rule that has anything to do with formatting, we don't want to care about. Prettier is what takes care of our formatting now. And this set of configurations and this plugin will take care of making sure that ESLint respects how we're formatting things with prettier. So with this in place, it means that when we run ESLint on CI, it will fail if some code is being checked in that isn't actually correctly formatted. So even if a member on your team doesn't have auto format on save set up, this will still be enforced, and so you can go and tell them that they did something wrong. We're configuring some rules just a little bit, and the only thing that really is interesting here is that we're turning off the recommended no unused variables and no undefined variables. And the reason why we're turning these off is that we're enabling the TypeScript equivalents right below it. So with this one, we're configuring it so it works for TypeScript instead, and then we're adding an ignore pattern. So I think that it's very nice to allow parameters and variables to be named underscore something, and then have ESLint accept those as, okay, these are not being used anywhere. For whatever reason, they still exist. Maybe it's a parameter that needs to be in place because it's not a name parameter. What's the opposite? A placement parameter. And we need the preceding or the succeeding parameter to be there. Or maybe it's a variable that we're not using at the moment, or for whatever reason, JavaScript needs it in some other way that isn't very explicit. So this is a helpful pattern, I think. Finally, we're disabling the no explicit any because we're going to be using that a little bit here. And you can argue that that is a TypeScript anti-pattern. I think it's okay. I think it's good to have no implicit any's anywhere in your code, which is what the strict setting in TypeScript will do per default. But if I explicitly type any somewhere in my code, I know that I'm doing something that's a little bit on the edge. And there's a good reason why I'm doing it. So I'm going to allow myself this. We will turn that specific check off. We'll add another file called .eslintignore, which will tell ESLint that node modules and dist folders should not be checked, because obviously that would be a huge performance issue and also completely incorrect. Finally, we'll add a script to our package.json to run lint, and I like to do it. Let me just copy this line. So we have our package.json in the root here. We just have the test script. We'll paste this in here. So I like to run ESLint with this formatter called Visual Studio. I can't show you just yet because we don't have any code, but as soon as I can, you will see what the difference is. So the normal formatter for ESLint will sort of group things together by file, and then it would say on line 2 and on line 10 and on line 13, there are errors in this file. With this particular formatter, you will get the file name and then the line number in a parenthesis, which means that you can click on it right down here in the terminal if you're using the built-in terminal in VS Code. So I just think that's a nice little thing. So that's why I specify this in my lint rule here. Then we specify that it needs to run through TS and TSX extensions. That is just what we need to do here. So that sums up ESLint and prettier. Now, the final missing piece of our architecture is our front end. And the reason why we haven't created any front-end folder or package.json is that we're going to be using a bundler called Vite. And Vite has some templates that we can use to help us create the basic scaffolding of everything we need. So let's try and invoke that. If we go to our services folder, we can run npm create Vite at latest, and we can call our project front-end. And it used to be that you had to specify a template here, but at this point, Vite just asks a series of questions. So we're going to tell it that we want the React template, and we want it with TypeScript. We're going to be using the regular ES build bundler rather than SWC. I think it should probably be fine with either, and SWC might indeed be faster, but at this point, let's just go with the default one. So we will now have a front-end folder for us, and we can run npm install in this. And you can see that Vite will have created a folder for us with quite a few files in it. So there's a whole bunch of stuff in here, including a package.json that has quite a few dependencies. And one thing to note here is that it has set up ESLint for us. And that is actually not really what we want, because we already had that set up in the root, and that's where we want to do our linting from. But it does add some nice plugins and rules, like the React hooks and so on. So we'll keep it just for now, and that is something we can refine later on. One thing we do want to adopt a little bit, though, is that you can see that it has added a tsconfig file for us. In fact, it's added two. And the reason for this is that the tsconfig file itself is where we configure TypeScript for our code, like the code that will become the front end. The tsconfig.node.json, which is, in my opinion, a little bit misleading. It should probably be called something like .vite.json. But that is the configuration for the Vite engine itself, because that is a Node project that runs in your terminal, and that needs to be using TypeScript as well. You can see here that it has a configuration file that is TypeScript. So it's running TypeScript as it runs, and that is configured in this file here. We're not going to care too much about that one right now, but we do want this configuration file to be updated a little bit. We can keep these settings as they are for now. So you can see it includes source in SRC the way we've done in our other projects, and that's fine. And the only thing we want to add is that we wanted to extend our primary configuration. And the reason for this is that we want to make sure that the references to the schema package are kept in our front end. And that's all we really care about at this point. We might refine some of these other settings as we go along, but for now, that will all be fine. But let's reference this or extend this basic tsconfig file and see if everything works. So I'll say npm run dev. And Vite spins up, and it says there's a server running now on localhost. Let's try and open that. And look, we have a little app running React, and we can click on this button and account will increase. So everything seems to be working fine, even with our specific TS configuration. Let's stop that. We're going to be using Tailwind CSS for styling of our front end. And if you're not familiar with Tailwind CSS, or if you haven't tried using it, you might feel similarly to how you might with Prettier. It is definitely controversial, and personally, when I first saw it, I didn't like it at all. But I found that after I've worked with it for a bit, I absolutely would hate to not use it on a new project. It is very addictive, and it's a very nice way to work, but it is something that is somewhat controversial. So you might find that this isn't for you, and then you shouldn't be using it in future projects, but that is what we're going to be using in this course, so now you'll have to bear with me a little bit. Let's install Tailwind by adding it to our front end. So we do that by adding some developer dependencies. Tailwind CSS, PostCSS, and auto prefixer. PostCSS and auto prefixer are dependencies of Tailwind CSS, so you just need to add those at the same time. And then Tailwind has a little script for initializing it, so we'll run that npx Tailwind CSS init -p. The -p, I believe, creates the PostCSS configuration file. So we run that, and we now have a PostCSS configuration file and a Tailwind configuration file. Let's open the Tailwind config file. So we want Tailwind to look at all of the files that we create that might have CSS classes in them. So the way it works is that Tailwind will provide a whole bunch of utility classes, and you don't want all of those to be included in your CSS bundle. So what it does is that it scans all of your source code for any string that looks like one of these classes, and if it finds it, it will include it in the bundle. And it's a confusing error situation to have that you are missing one of these classes because Tailwind didn't discover it in your source code. So it's pretty important that you get all of the source code included here that you might be adding CSS classes to. And we may not be adding anything to index.html, but let's just include it for to be absolutely sure that we have everything. So one thing to note here is that Vite puts the index.html in the root folder of the project, not in the source folder. If you're not familiar with Vite, that is something that might trip you up, but just keep in mind that it sits there. And then we're going to include all of our component files, and all of those are in the source folder, and they're called either, let's just include JavaScript, so JS, JSX, or TS, or TSX files. And the reason why we're including JS and TS as well as the X files is that we might have some logic in just a plain TypeScript file that concatenates some string and returns a CSS class from that. I don't know if we're going to have that, but just in case we do, we don't want Tailwind to miss it. That's why I'm adding JavaScript as well here. We're not actually going to be writing any JavaScript code, I don't think, but just in case we do create a JavaScript file, it's nice that it is automatically included. So now that we have that set up, Tailwind should find it. We will then change the index.css file. So this index.css file refers to all of that we had on this page here, and we're not going to be using any of that. So let's just get rid of all of this and just add the Tailwind directives. And there are 3 of them, and we'll just add those. Those are just, there are some more, I think, but these are what the basic configuration is. Base, components, and utilities. And you can see I get little error or warnings here. That's just because VS Code doesn't know about Tailwind. I'm not actually sure why that is, but it's a warning that you can safely ignore because PostCSS will pick this up. We will then, we can get rid of this style sheet file, and the main just renders an app, so that is fine, and that opens index.css, so that is fine. The app file we can just clear, and we will just add, let me just copy this from the article, this very, very simple component. We can also get rid of, let's see, the assets folder. We don't need that, and we also don't need this logo here in the public folder anymore. There. So now what we should have is just a basic div with an H1 that has text for Excel and text Indigo 700. So the text for Excel will set the text size, the font size, and this one will set the color. And you can see I have little hints here. That is from a VS Code plugin called Tailwind CSS IntelliSense, I think. And if you're using VS Code, I highly recommend that you install that. It is tremendously helpful when you're using Tailwind CSS. So let's try and run our server again and see if we get a page that now reflects this. Hello world. That looks indigo to me. Perfect. Let's get started with the database and our schema. As you know, we're going to be using Postgres for our database. There are a number of ways you can work with databases, and different companies do different things, but I think it's nice to have one production database running, and then every developer has their own database running locally. That makes it very easy to try out migrations and test different things with a database without messing things up for other developers. So we're going to want to install Postgres on our local machine if you don't have it already. It's trivial to do this using Docker. It's basically a one-liner. Let's try and run that. I will go into my shell, and I can do that from this folder. It doesn't really matter. I will just run this Docker one-liner that says run, specifying a name. We'll call this easybooking_db, and we'll give it 2 environment variables, which is Postgres password and Postgres DB. Those are required. And then we will initialize the Postgres image. And this is the official Postgres image from Docker Hub. We're not going to add a tag to specify a version or anything. If you run into more advanced features and you need a specific version of Postgres, that is something I would recommend you start specifying. Also, you should try and keep the developer version in sync with whatever your production version is. But for now, we'll just take whatever is on there and we'll start it like so. And since I already have the image on my machine, it's very quick to start. You can see that it should be running. If I list it here, I now have a Postgres server running on port 5432, which is the official and standard port for Postgres. It will take a little bit to download on your machine. With that in place, let's try and do something with our database. We're going to be using a library called Next.js. At least that's what I think it's called. I'm not actually sure how to pronounce it. Next.js is a query builder, which you can say is really just a glorified string concatenation machine. So it's different from an ORM or object relations mapper in that it's working with SQL, not with objects. And if you are mostly used to working with an ORM, you might consider this a limitation or a weak abstraction. And I guess you're right, but in some sense, at least I find that it's very nice to work with query builders rather than ORMs because it really gives you access to the full power of Postgres. And I should state that I'm by no means a SQL expert, far from it. I'm much more comfortable writing in my GPL, general purpose programming language, but I still think that it's very nice to be able to access Postgres and all the features that it offers. Postgres is a rock-solid piece of software, and it offers many things that you wouldn't want to limit yourself from, which an ORM will often do, at least the ones that I've experienced with. We'll start by installing it in our schema package. And the reason for this is not that we're going to be writing actual queries in the schema package, but we will be using it for migrations. So Next has support for both migrations and database seeding, and we're going to be using both of those. And so we need the package installed in our schema as well. So let's go to the schema folder and we'll add Next and the Postgres driver, which it also needs. And then we will create a configuration file for it. And just similar to what we've done with other tools, Next also has an init script which can create a configuration file for you. But we're not going to be using that right now. It can actually create TypeScript configurations for you, but I've just found that there are a number of limitations to that that I feel are not worth it. So we'll create this configuration file as a JS file in here. And maybe at some point in the future, I will switch to TypeScript. So you can see here that it exports just a development configuration. And the reason for this is that we will just be using this for migrating our own developer machine. This is not the configuration that we use to connect to production database. We'll be specifying that in the backend package. You can see that we have a linter error here complaining that we're using the old-fashioned require syntax. Obviously, it would be nicer to switch to ESM, but I've had some issues getting Next to support that. I'm sure it's possible, but I just didn't feel that it was worth it for this because it's just a configuration file. So let's just disable this for now, like so. So you can see here that I'm specifying that there's a migrations folder, and it's in the schema package folder and then in migrations, and that doesn't actually exist yet. So let's just go and create that. There we go. We now have a migrations folder, and that is what the configuration is set up to use. So let's try and create our first migration. So we use the npx, which runs, we can create a script for this in our package.json if we want to, but for now, let's just use npx. So we can say migrate make, and then we can specify the name of our migration, and let's just call it initial setup. So you can see that Next has now created a file for us here. So it's prefaced with a timestamp, and the reason for this is that it's very important that migrations are run in order. And so with the timestamp here, we're specifying which part of the order this migration is in. And it has created a little scaffolding for us. At times, I have changed this to actually import SQL files, but for now, let's just keep it like it is and just use next.raw to specify SQL in here so that we can migrate our database with some simple SQL statements. So I'll just copy something from my article here. We'll use this to create a table called users, and then for the down migration, we will drop that table. Whoops. So a quick note on down migrations. I don't think that in my entire career I've ever used a down migration in production. So I don't consider these to be very important. What I use them for is basically when I'm developing my migration. If I'm not happy with it, I run the down migration in the command line to down migrate my development database. I don't think I would ever do it in production. And the reason is that database schemas don't live on their own. They're not an island. They are connected to things in external services and possibly other things that like emails might have been sent. So just down migrating a database doesn't mean that you roll things back. Sadly, things aren't that clear cut. So what I have almost always done when I need to undo a change to the database is that I will write a new migration that reverts those things. So it's sort of similar to the revert commit in Git instead of undo commit, which I might do on my local branch, but I very rarely do on branches and things that have been pushed to GitHub or wherever I have my repository. With this in place, let's try and run it. This is the command line. Oh, I'm missing that. Next. There we go. And see if it can connect to our database. It looks like it can. And so now our database should have this users table. And it should have an ID, an email, and a password. This is just a silly little table that we're not going to be using. I just wanted to try and get something up and running. Now that we have a table in place, let's try and use Kanel to generate types or type from it. We'll install it as a developer dependency in our schema package together with the next plugin for it. So I'll add Kanel and Kanel next like so. And then we need to create a configuration file. So Kanel doesn't have an init script or anything, and so we'll need to create this manually, and we are going to create it as a JS file again. So the same applies here. I should probably change it so that you could configure it using TypeScript, but I haven't done so just yet. So we'll need to use JavaScript for this as well. So I've just copied a tiny configuration file here that I'll just quickly go through. First of all, we need to specify a connection, and we're doing this by importing the next file that we already created so that we make sure that we're using the same developer database as the next file specifies. So we can basically access that through this. Then we need to specify where it should create the model files, and we're going to use an output path here because I often find that I need this for other things in the configuration, so this is just how I normally do it. I'm basically specifying that it will go into source/models. We will tell it to pre-delete the output folder every time we run Kanel. I like to do this. It means that you can't put any other file in your models folder because that will be deleted as well when you run Kanel. On the other hand, if you were to, say, delete a table or rename something, you will make sure that you don't have any cruft sitting there that isn't in your actual database anymore. This is a way to guarantee that. Then we're specifying this type filter here. And what we're doing with that is basically making sure that the two next migration tables aren't included. So Next has created, or when we ran the migration, it has created two tables for us. And we don't want to create types out of those because those are basically just utility tables that we're not going to be using in our code. This filter is a predefined, so that's from this plugin package. It will just filter those two out. So the way we just do that is specifying this. And then finally, we're adding a generate index file hook. What this does is that it will take all of the model files, and it will create one index.ts file where it exports all of those once and for all. It's just a little helper. I just find it's nice to have. It's not necessary. You might want to import them by specifying the paths instead, but this makes it a little bit easier for you. So with this in place, let's just save it and try and run Kanel. So I do that like so. And it says that it starts clearing all files in source/models, which obviously didn't exist, but you can see it has now actually has created a source folder for us, which we didn't even have. But so that exists now, and in there, that's just a models folder. The models folder contains one folder for each schema, and we just have the public schema in our Postgres database. The reason why it's called public, I think, is historical. It's something about Postgres used to have just one schema initially, and that was the public one. And when they then added multiple schemas or support for that, they had to name the first one public, and so that's why it's called that. You can change it to a better name if you want, but we're not going to do that right here. You can see that we have a users.ts file here. So this is what Kanel has created for us. There are three interfaces, the table itself, or the selector, if you will, the initializer, and the mutator. So this one is used when you want to insert something into the users table, and this one when you want to update something. And these two resemble this one very much, except that all of the things are only required if they are actually required for initialization or updating. So for updating, nothing is required. So all of the fields here are optional. When initializing, you can specify an ID, but since the ID has a default value, you don't need to specify it, and probably you never would. So when you create a new thing that you want to initialize, you would probably only specify the email and the password, and pass that to the insert script, and then the database would create the ID for you. One final thing to note here is that we have a user's ID type. It is basically just a number type because the ID was just a number, but we want to create this as a branded type. What this does, if you're not familiar with branded types in TypeScript, it's basically a way to sort of pretend that we're doing nominal typing. So TypeScript per default is structural typing or doc typing, which means that any two objects that have the same fields in them will be considered to be equal types. And that is a very nice feature. It's one of my favorite features about TypeScript, actually. It's a very nice way to work. But there are a few situations where you might prefer the other type system type, which is nominal typing. And that basically says, well, if you have a duck and a goose, even if they both have the same methods and properties, they're not the same thing because they have two different names, basically. And IDs are one such thing where I personally find that is very important. An ID is typically the same underlying type for all of your tables, either a number or a string for a UUID or whatever. But if you accidentally call a function that takes an account ID and you give it a member ID instead, at least if you're using numbers and those are just sequential, so you could actually be passing on something that is a valid member ID and not account ID that you meant to pass, it is a very bad situation. You can alleviate this a little bit by using UUIDs, which means that you're very, very unlikely to pass something in that is actually a valid ID for a different table. So that helps a bit, but it's still just runtime safety. With this, you will get compile time safety. So a user's ID cannot be used for a function that takes a member ID or account ID or something else, even if it's both still just a number. So the way this type is constructed is that it adds this brand structure that isn't really used anywhere and will be removed completely when you compile it to JavaScript. So this adds no runtime overhead whatsoever. It only provides some compile time safety. Right. So one last thing I want to do is that I want to create an index file here so you can see the index file that has been created from the plugin that we use, or the extension, that exports the initializer, mutator, and selector, as well as the ID in the models folder. So we just want to create an index file out in the source folder that will export all of the models. Oops. So we'll just do export everything from models there.
Thanks for watching. If you want to keep learning, click the link in the description below.